This session, basically, you've been introduced to a bunch of different concepts. This session is really about practical approaches to building Bayesian networks. So this first session is something that we probably have to reorganize. It's a grab bag of ideas about how to simplify the process of building networks. And yeah, so you'll get to see lots of different techniques, simplifications, and things that you need to keep in mind while you're doing the modeling in this session. In the session after, we're going to do focus exclusively on Delphi. And we're going to do a practice Delphi exercise, one that's a little bit more practical and useful, and you'll get a sense for what it's capable of and what it can do. Okay, so there's a couple of references here if you wanted to read. There's a good blog by Anne that she wrote, which was like a rundown on quickly putting together a Bayes net, which is quite useful to read, I think. And there's also Kevin and Anne's book. There's quite a lot of information there on building networks. Okay, so the basic principles behind building a Bayesian network are actually going to be fairly familiar to you because they're the same kinds of principles that you see in software engineering. Okay, so the key thing to focus on is that you want to be iterative and incremental. So this is the same kind of thing that you would see, in an agile software process or other kinds of iterative processes. It's the same kind of thing. So first you want to get a clear sense of what the objective is, which is kind of like a requirements analysis. You want to go through the construction of the model, design and implementation, and you want to evaluate. So that's the spiral model process. Is everyone familiar with the spiral model? I would assume so, yep. So it's exactly the same kind of thing. So back in the earlier days of Bayes nets, a lot of the people that were building them were also software engineers and realized that a lot of the same techniques could be brought across. And so you go through the same process. Okay, so you've got those three main kind of categories. You've got the defining the objective, the task objective, building the BN, and evaluating. So let's talk a little bit about the objective for building Bayes nets. So there's various purposes that you could have in mind when you're building a Bayes net. So it's not a strictly one purpose kind of model. You can apply it to different kinds of tasks and ideas. So one thing that you might want to do is apply it to decision making. That's the most obvious case in which you want to apply a Bayes net. So you model the system so that you can work out what the impact of interventions, for instance, or how a particular system will play out so that you know how to react in response. You may want to do just prediction, like forward prediction. So a lot of you might be familiar with neural nets as well. Neural nets are extremely good at prediction, but not, don't give you a very good sense of why it predicted what it predicted. So Bayes nets are also good at prediction, not quite as good as neural nets at the moment, but they will explain why. You will get a sense it's very transparent what's going on. You've got retrodiction. So basically, why did something happen? You want to model a situation and say, okay, this was a really bad thing that happened. Why did it happen? You can work backwards. You can use it for monitoring and control. So you build a model of how a system is supposed to work. You put in evidence about how that system is working. And then if something's slightly off, it can flag it for you and say, okay, there's some issue here. It can be used for explanation, which is a little bit like working backwards, but you might work backwards and forwards in an explanation. You might be trying to explain why a system works the way it does. You can use it also for sensitivity analysis, which is essentially, building a model of a system and saying, well, if we change the tolerances here, how much does it affect the output? Or if we tweak this, by only a small amount, but if we add some noise to this, is it going to produce a big difference? So you can use it to do sensitivity analysis. Of course, you'll use sensitivity analysis to analyze your network, but you can also use that to then analyze some system. And the information value. So working out if you learn something about X, some more information about X, whether it's worthwhile doing that. So if for instance, you're considering whether to spend a lot of money to do some research on some topic, instead of doing all of that first, you create a model to see if it will be worthwhile doing, and then if it is, then you proceed. Okay, so it's really critical. So you guys probably won't be building a lot of Bayes nets yourselves, which are for any specific application, but you'll be building a lot of kind of toy models, test models to make sure that the software is working the way it should be. I'd recommend that you also build those models for your own purposes. So as you're building the software, go through and try to model your own decisions with the software, and to make sure the software is usable. So make sure that you're dog fooding your software, basically. Otherwise, you're going to produce bad software. Okay, so you need to be building these models. You need to be understanding how Bayes nets work and how they'll be implemented in the system. So when you're doing that, you've got to have a very, very clear purpose of what the BN is supposed to do. Okay, a very clear sense of that purpose. If you're a little bit fuzzy on the purpose, you can build a Bayes net which is very complicated and includes lots of things that are totally useless. And if you're overly narrow, you might find that you build a very specific BN and then you have to throw the whole thing away and then start with a new one. So you've got to have a very clear sense of purpose, because that gives you a good idea about what to build. Okay, so there's various stages that you go through when you're building a BN. These are all pretty straightforward. You've already gone through them all, but you should go through them in a formal sense. You should say, okay, have I, at least addressed this issue first, then moved on to addressing this issue and so forth. So it doesn't have to be in order. It can be out of order, but you just need to make sure that you're, ticking off all the boxes. Okay, so when you're working with probabilistic models, the three stages are, making sure that you've covered all of your variables and not more variables than you need. Okay, so you want to make sure that you've got the right set of variables. You want to make sure that you've got good values. You specify appropriate values and states for those variables. Okay, so this is very important. Getting a good definition of a variable can be the difference between a model being completely useless and being, very, very easy and quick to use. So getting definitions down right is very important. Document. I mean, you know that from software engineering, but that's critical. And in this particular context, in terms of, we're actually proposing to create what's called augmented causal Bayes nets. In a sense, we're building the documentation into the process. So that's going to be a critical part of it, making sure that you've got good definitions for nodes, good definitions for states. Okay, so there's the graphical structure. So you've got the arcs between the nodes. That's obviously, quite key. You're going to be doing that at the same time as you define the relationships between nodes. So when I talk about relationships here, I'm not just talking about, is X related to Y. I'm talking about what kind of relationship do the parents have with the child? What kind of relationships should exist in the wider network? Okay, so that's a little bit beyond what the graphical structure actually involves. And I'll talk a bit more about that shortly. Obviously, there's the parameterization and the local model structure. So that's specifically about the relationships between parents and children. Okay, so that's Bayes nets. So that previous slide is just about when you're building just causal networks or probabilistic networks, and you're not modeling actions or decisions. But if you need to model decisions, then it's appropriate to start adding decision nodes and utilities. Okay, so then you want to say, well, what are our available actions? What can we do? And you also want to identify at this stage who the actors are. So, you want to work out who the actors are and who are the people affected, who are the stakeholders affected. You want to work out what the utility nodes are, of course. So basically you want to say which outcomes do we want to value. Which ones do we value, which do we think are important, which ones aren't important. And you want to focus on, making sure that you get that right. You don't want too many, you could attach costs to everything and costs and benefits to everything. And that would be really complex. You could say every single combination has a slightly different cost. You don't want to do that. And it's a little less clear than when you're building a probabilistic structure. because there you can use causality to kind of guide you. With the utilities, you haven't got that guide. What you've got is, does this really matter to me? Does it really matter to the stakeholder? So that's your guide. Okay, so then once you've determined, what you want to measure in terms of the value, then you need to actually get those preferences. So you usually have to go to your experts, your stakeholders, elicit those utilities from them in some way. Sometimes that can be easy. If it's dollar amounts, it's really, really trivial and straightforward. It's almost never just dollar amounts. So in that case, you have to work out some way of measuring what their values are. Okay, so the different tasks involved in knowledge engineering. There's different ways of approaching all of these construction tasks. So there's kind of two broad approaches. There's the expert-based approach and there's the data-based approach. So those are the kind of two major techniques. Use data when you've got it, but only if it's good. Okay, so that's kind of the key thing. If you've got good data, use that. Don't waste too much time with experts. Okay, but that's pretty rare. Having good data is very rare, so we're forced to rely on experts a lot. And in this project, it's pretty much all expert-based. So there will be, I think in later stages, I'd recommend doing some kind of data learning from the experts. That will be a little bit different, but for the most part, this project is very expert-driven. So, okay, so you've got expert elicitation, can apply to every single phase of the construction process, obviously. There's automated learning, which is very good for probabilistic models at the moment. Some cases better than others, but it's quite good across the whole process if you've got good data. For the utility-based things, for decisions and utilities, at the moment, there's not much out there, which, in terms of the automated learning. And you guys you guys may actually develop some techniques for doing that. But that would be much later down the path. So, okay, and then you can combine expert elicitation and data. So probably won't talk too much about that, but basically you're usually doing some patch between the two. Okay, so that's the basic process. As I said, it's essentially a spiral model that we've got from software engineering, so it's exactly the same. It's very important to use a prototyping process. So you're starting off with a very small model of your system. You're making sure that small model is a really good, accurate representation of what it's modeling. And then you're building on it incrementally. And each incremental change that you build to the model, you want to test, make sure that it's working, as you expect, as the experts expect, and so forth. So it's almost identical to what you would do in software development, in any good software development project. You're constantly doing this tight iteration. And you can see it now with, even major software, developers, and they've all gone to this iteration model. So all the current browser makers, for instance, are on a six-week iteration. They release something every 6 weeks because they want to get that really tight feedback loop. So this is kind of critical to producing good models, good software. It's all the same. Okay, so prototypes are obviously good for lots of reasons. They minimize the overall risk. You're not diverging too much from what the users expect. So you make sure that you're, actually sticking to the objective, to the idea. You're making sure that the objective makes sense at each point. That, if it needs clarification, you're doing that continuously. And you're always doing the testing. So, you're always getting the right kind of feedback as you're going along. So no product that you produce at the end is going to be perfect. No product is perfect. Unfortunately, a lot of users think that products are perfect or could be perfect, but no product is perfect. Everyone using a piece of software is going to be slightly different. There's always going to be different groups of people who conceive of the world in different ways. But so long as you're iterating with everyone on a regular basis, you can get basically the common features that everyone wants. You can lock those down and make sure that they work really well. Okay. All right, so we're going to be talking about each of these pieces in turn. So we're going to be talking about expert elicitation, how that applies to the structure and the parameters, learning from data, how that applies to structure and parameters as well. So that session is actually going to be this afternoon with Kevin. But for the next couple of sessions, we're going to focus on expert elicitation. And Kevin will also talk about evaluation a little bit.